leave that up for a few more seconds. All right. Okay, so what if we wanted to find the domain? Bring that down a little bit. For, let's say you have the function f of x equals 1 over the square root of 17x minus 34. Oops, straighten that up some.
This is 17?
Yep, 17x. Let me clean that one up a little bit. There we go. Okay. So this is one of the cases where you have to worry about both a denominator and a square root. So you use both of those little hints from before. Okay. So we know the denominator can equal 0 and the radicand has to be greater than or equal to 0. So both of these would have to be true to find the domain for this one. Okay, so if the denominator can equal 0, that means 17x minus 34 can equal 0. Or really the square root of it, but if you square both sides, the square root kind of disappears. And also, since the radicand has to be greater than or equal to 0, and that's your radicand, that means 17x minus 34 has to be greater than or equal to 0. Okay. So here, if we square both sides, the square and the square root will disappear. So you have 17x minus 34 can equal 0. So if we add 34 to both sides, (17x), let me clean up that 1 there, can equal 34. Divide both sides by 17. You know the x can equal 2. We'll clean that up a little bit. Okay, so we know that x can equal 2. And, because remember both of these conditions have to be met, we get this one. Again, just add 34 to both sides. I'll put that under there. Yep, so you end up with 2 again. 17x is greater than or equal to 34. Divide both sides by 17. Since we're not dividing by a negative number, the sign doesn't switch over. So you have x is greater than or equal to 2. Okay, so we know that x can't equal 2, and x has to be greater than or equal to 2. Okay, so if we know that x can't equal 2, we know it's going to be an open circle right at 2. But we know that x has to be greater than or equal to 2. Because just for this one, that means if it's not equal to 2, it could be anything on the left and anything on the right. But this let us know that anything to the left, you can't include it. Because it has to be greater than 2. Well, greater than or equal to 2. Yep, so just includes everything to the right.
But the 2 is not included.
Yep, 2 is not included. But everything to the right of 2 is. So everything there is included all the way to infinity. Everything to negative infinity, yep, you can't include that. Does that make sense? All right, that's why drawing this kind of helps a little bit. It helps you visualize which part you need and which part you get rid of. Okay, so that means your domain, which is everything over here, is from 2 to infinity. You have a parentheses because, about to draw a bracket for some odd reason. Because you have an open circle. All right, so any questions on that one? Okay. All right, leave that up for a few more seconds. All right, looks like everyone's done writing. Okay, so now we're going to look at what they call piecewise functions. Okay. So a piecewise function is when you have for a certain part of the domain, you have one function, then for a different section of the domain, you may have another function, then a different section, you may have a different function. So you can have various functions all on one graph where you could have a different function for each portion of that domain. And I'll draw that out for you. So a piecewise function can have several functions on the same xy plane. But they're all functions of x. So to kind of help visualize it a little bit, we can look at two graphs. Okay. So let's say our first graph is just f of x equals x. Okay. So f of x equals x is just a slanted straight line. It looks like that. Okay. So what if we also have the graph of x squared? That's your x, y axis there. And x squared kind of looks like a u. So this is f of x equals x squared. So what if we decided that from negative infinity all the way to 0, we want our function to be x. But once we go to 0 all the way to positive infinity, we want it to be x squared. That's when we just kind of piece those two together. So let's say if you have f of x equals x as long as x is less than 0. Okay, so all the way up to 0, it's just going to be f of x. But then once you cross 0, So for x greater than or equal to 0, that f of x is going to be x squared. And this actually should be down a little bit. I make that a little too high. There we go. So it's usually right towards the middle. Okay, so if we wanted to graph that, we go ahead and draw our xy axis. And we know that all the way up to 0 is going to be f of x equal x. So that means we get our f of x equal x, and we'll draw it all the way up to 0 and stop. So it'll look just like, uh-oh, can't do that.
Turn on the light again.
It's okay, but then it kind of fades. Let me try something, see if this works. There we go, I'll do that. Yep, so all the way up to 0, that's how it's going to look. But then on the other side of 0 is going to look like this one. So it's kind of two different graphs pieced together. Okay, so all the way up to 0 is going to look like that, which is just 1/2 of that first one. Now on the other side of 0, it picks up and becomes the x squared. So this is your piecewise function. Okay. Does that make sense? All right. Any questions on this so far? All right, leave that up for a few more seconds. Alright, so let's start off with a couple of examples. Okay, so let's say we have,
I can't see.
oh, sorry about that. I think it's trying to adjust to my skin tone against the paper. So we have the piecewise function. I'll make sure I leave a little bit of time to let you write it down. And it's f of x equals, the first one is x plus 1. Uh-oh.
I think if you bring down the bond
Yeah.
paper so it shows more of the desk, it won't color adjust as much.
Nope.
So like, no.
No, bring the
Like
paper.
bring down,
Oh,
bring
bring-
down paper so there's more of the desk showing. Now, right? Yeah.
Yep, yeah, still. Let's do it. Okay.
Why won't you turn the light of the room and I won't be my teacher?
Will you be able to see the
We can
screen if you do
try.
that?
Yeah.
Oh, okay. Try that and see if that works.
No, turn it around.
Back glare, kind of. We'll try that. I don't think that's too much of a difference. I think it's just a,
Oh, it's perfect.
oh, okay. Well, that did work. Good idea. Oh. Oh, let me change my pencil lead while you write that. There we go. So it's x plus 1. And that's when x is less than 5. But it's x squared plus 4 when x is greater than or equal to 5. And we want to find f of 3, f of 7, f of